In this lesson, we want to be able to say that I can determine whether a relation is a function. Remember, a relation is a set of ordered pairs. Remember, we have the set symbol with our curly brackets, and we have a bunch of ordered pairs. Let's say we have 3, 2. Let's say we have 5, 6, 7, 8. This could be a relation. It's a set of ordered pairs. We could have more in there. We could have less in there. It's a relationship between our ordered pairs. Function. A function is a type of relation with every element in the domain paired with exactly one element in the range. That's the key word, exactly one. So we know it's a function if we know that for every element in the domain, it goes to exactly another element in the range. In this example, we want to determine whether each relation is a function and also explain. We have -2 going to 5, we have 0 going to 5, we have 2 going to 5, 4 going to 5, and -2 going to 5 again. Well, this right here is a function. The reason why it's a function is because every single element in this table, in this relation, goes to exactly one other element. They just all happen to go to 5. Part B, is this a function? Well, let's check each point. -8 goes directly to +2. -6 goes directly to +7. -5 goes to +6. -4 doesn't have one. -3 goes down all the way until we get to -6. -2 goes until we get to +8. 2 goes to 2. 5 goes to 6. 6 goes to -5. 7 goes to -5. And 9 goes to 6. So this right here is a function as well. Every x value goes to exactly one y value. In part C, we have the domain, we have the range. Notice that 2 goes to both 0 and 3. Because 2 goes 2 spots, this is not a function. We don't know where 2 goes. We do not know if it goes to 0 every time or if it goes to 3 every time. We know that a function would go to only one output. We know that the function of the domain would only go to one element in the range. In this example, we're asked to do the same thing. We're determining whether these are functions. So let's check. -3 goes to 8, 0 goes to 9, 2 goes to 2, 0 goes to 1, 5 goes to 12. You may say, oh, well, that's good. However, our issue becomes at the 0. Notice we have 0 twice on the x value. Because we have 0 twice on the x value and it goes to 2 different numbers, we do not know if 0 goes to 9 or if 0 goes to 1. So this is not a function. Part B, we have this graph. Notice with -8, we're going down till we get to -4. At -6, we're going up to +6. At -3, we do not know if it goes to 1 or if it's going to go to 4. So this one would not be a function because of those 2 points. With part C, we have -5 going to 2. We have 2 going to 3 and 7 going to 2. None of the numbers in the domain go to 2 different values in the range. So this one is a function. A relation or function is discrete whenever the points are not connected. It has a clear starting point and a clear ending point. A relation or function is continuous if we have a graph that is unbroken and we represent it with a line or a curve. We can test to see if a relation is a function by using the vertical line test. The vertical line test says that if a vertical line intersects a graph more than once, then the graph is not a function. If we look at the example on the left, what we are going to do is we are just going to draw a vertical line in a random spot. Notice that this vertical line only passes through once in that one spot. But if we were to draw it somewhere else, let's say right here at 5, then we notice that this passes through the graph at this point up here. It passes through it again down here, and then a third time there. Because it passes through this relation more than once, we know instantly that this is not a function. In the example on the right, let's do the same thing. If we were to draw vertical lines, Notice it only goes through the graph once. Right here, remember that a open circle means that it does not equal that value. A closed circle means it can equal that value. And which means that at -4, it passes through. It only goes through once. However, at +2, it goes through both 4 and at -2. So this right here would not be a function because that vertical line passes through 2 points at the same time. We wouldn't know if the function would go to 4 or if it would go to -2. So this is not a function as well. In this example over here on the left, let's go ahead and draw ourselves some vertical lines. Notice it only passes through the graph once. Let's draw one maybe at -4. Passes through only once. No matter where we draw a vertical line with this graph, it's not going to pass through this continuous relation more than once. So this one is a function. In the example on the right, let's do the same thing. Let's draw some vertical lines. Let's put one at -9. Let's put another one at -6. Let's check where these piecewise functions jump up or down. That passes through only once because you have the open circle, which means it does not hit that point, and then you have the closed circle, which means it does. At x equals 0, also good because you have the open and closed. At +2, we're also good because it's open and closed. And lastly, at 5, we are also good because you have the open and closed dots there as well. So this one, no matter where you draw your vertical line, this one would be a function. At a pumpkin growing contest, each pumpkin's weight was measured to ensure it was within the regulated range of 0 to 30 pounds. The measurements were as follows. Contestant 1 was 19 pounds, contestant 2 was 22 pounds, contestant 3 was 27 pounds, contestant 4 was 19 pounds, contestant 5 was 25 pounds. We want to make a table of values showing the relation between the contestant and the weight of their pumpkin. So what we're going to do is we are going to just create ourselves a table. Now since we have our table, we're just going to label our contestants. We have contestant 1, 2, 3, 4, and 5. We know that contestant 1 was 19 pounds. We know contestant 2 was 22 pounds. We know contestant 3 was 27 pounds. We know contestant 4 was 19 pounds. And contestant 5 was 25 pounds. And this is our table. Part B. State the domain and range of the relation. Then determine whether it is a function. We're going to use D for domain and R for range. The domain of this is we have 1, 2, 3, 4, and 5. There are 5 contestants. For our range, we have the smallest number is 19, then we have 22, then we have 25, and lastly 27. Notice we do not have to write down 19 twice. Whenever we are listing out our domain and range, we only have to list each number exactly once. Part C. Write the data as a set of ordered pairs, then graph the data. So first, we're going to take our table. Our table was up here, so let's go ahead and just write that down as a set of ordered pairs. And this is our ordered pairs. So taking this from our table, we would see that these are the ordered pairs. Now let's graph it. Let's go ahead and make ourselves a graph. We don't have any negative values, so we just have to worry about quadrant 1, which is the positive values of our x and y. Let's label a few things. Putting this on the graph, we see at 1 we are at 19, so that's just a little bit below 20. At 2 we're at 22, so we're going to be about up here. At 3 we are at 27, which is going to be a little bit over 25. At 4 we are at 19, so we're going back down. And at 5 we are at 25. Of course, you want to take graphing paper if you want a more accurate graph. State whether the relation is discrete or continuous. Explain your reasoning. Well, this is discrete. The reason why this is discrete is because we cannot have a partial of a contestant. We know that we can only have 1 contestant, 2 contestants, 3 contestants. We cannot have a 1.5 of a contestant, a 2.7 of a contestant. So this would be a discrete function. It's a function because every single input, all the x values, have exactly 1 output. Contestant 1 had a 19-pound pumpkin and not another pumpkin. So we know that this is a function. So remember, a function is a special relation. The last example we are going to do is the following. We want to determine whether these are functions. Well, first thing we're going to do is we need to graph this. So in order to graph this, let's go ahead and just make a table. Let's pick some x values to be able to get some y values. Let's choose the x value to be 0. If x was 0, y would be 10, because this would be 0 plus y equals to 10, so y is 10. If we chose x to be -1, we would see that this is -4 times -1 plus y equals to 10. So in other words, this is 4 plus y equals 10. Well, 4 plus what equals 10? Well, 6. So y is 6. So putting this on the graph, this is going to end up to be 0, 10, and -1, 6. Let's see if we have any more points. Let's try -2. If we try -2, this would end up being -4 times -2, which is +8, plus y equals to 10. So 8 plus 2 is 10. So -2, we are at +2. And we could choose some points in between. We could choose some decimals. This would be a continuous line. In fact, this would be a continuous straight line. You will learn in some other videos that this is a linear equation, and all linear equations are functions. With this other equation, we have 5x equals to 10. So let's just choose some x values. Notice we do not have any y values in here. Something interesting about this is that if x were, let's say, 2, the y value in this case can be anything. We do not know where the y value is. The only x value that we have here is 2. The y value could be 5, it can be 6, it could be 7, it could be 0, it can be literally anything. This 2 can go to any of these. So because of that, this is not a function. By the way, graphing this out, we would end up with what's called a vertical line at x equaling 2. So our graph will look like this.